Hey kiddos, we're back. We're continuing our discussion on states of matter, and today we're going to talk about liquids and solids. I'm going to give you some properties of liquids and solids. Perhaps you've heard these before in your junior high or middle school experience. So for liquids, liquids, like gases, can flow. Now their particles are much closer to each other, but the intermolecular forces of attraction are such that they allow them to move past one another. So liquid particles can flow. Number two, liquids take the shape of their container. But unlike gases, they do not occupy the entire volume of their container. So I could have a beaker that's half full of water. I could pour it into a large flask. It'll take the shape of the bottom of that flask. It'll occupy a fixed volume. It'll take but it won't occupy the entire volume of that container. Number three, as I just said, liquids have a definite volume. That's because their intermolecular forces of attraction keep them stuck together. And number four, the particles are so close to each other, they are essentially incompressible. Now I know some could argue with me and say that you can compress liquids a little bit, but essentially for our purposes, liquid particles are so close together we can't push them any closer together, so we're going to say that they are incompressible. A couple of vocabulary terms related to liquids. The first is surface tension. Surface tension is the energy required to increase the surface area of a liquid. And that's due to their intermolecular forces of attraction. The stronger the intermolecular forces of attraction are, and we're going to talk about those intermolecular forces of attraction in an upcoming video, the stronger those forces of attraction are, the more energy is required to spread that liquid out across the surface. So the energy required to increase the surface area of a liquid is called surface tension. Water particles happen to have a fairly high intermolecular force of attraction for one another, so water has a high surface tension. It almost acts the surface as a film, and so you can see this water spider, or water skeeter, we call them as kids, standing on the top of the surface of water. We can even take a paper clip and place that paper clip on the surface of the water. And even though it's denser than water, the paper clip, the surface tension of the water will allow that paper clip to actually float on that surface. Viscosity, another vocabulary term related to liquids. Viscosity is simply resistance to flow. So some liquids have a high resistance to flow. If you want to think of a highly concentrated sugar solution like maple syrup has a high resistance to flow. Other liquids have a low resistance to flow. Water doesn't have a very high viscosity. It has a fairly low resistance to flow. So these are also related to intermolecular forces of attraction. All right, properties of solids. Well, solids, as you know, do not flow. Solid particles are so strongly attracted to one another that they can't move past one another in their solid phase. When they form those crystal lattices, they can vibrate back and forth and up and down, but they can't move past one another. So we say that solids do not flow. Solids have a fixed volume, just like liquids do. But they don't take the shape of their container. Solids have a definite shape. I can put some marbles inside of a container, and those marbles have a definite shape. They don't take the shape of their container. I could throw a rock in a container. It certainly does not take the shape of that container. And once again, That's related to the crystal lattice that's formed in solids, and it joins those particles, those solid particles, together so that they can't flow past one another. And if they can't flow, they can't take the shape of their container. And solids are incompressible. Once again, that's related to how close the particles are to one another. And we can't push them any closer than they are to each other, so we say that they are incompressible. Okay, so just a couple of properties for both gases, liquids, and solids, and some vocabulary terms related to them. Now I want to move into a topic called forces of attraction. And this is actually pretty important to understand intermolecular and intramolecular forces of attraction. So we've already discussed the intramolecular bond. This is the bond that holds atoms together within a molecule. So do you remember when we did ionic bonding and covalent bonding? We drew Lewis structures. We talked about shared pairs of electrons. Okay, those are all intramolecular bonds. So, for instance, the covalent bonds that hold hydrogen atoms to oxygen atoms in the water molecule are an example of intramolecular bonds. Or the ionic bond that holds sodium and chlorine ions together in the compound sodium chloride are also intramolecular bonds. So there are actually three examples. One of the three we didn't talk about too much in class. But ionic bonds are intramolecular forces, covalent bonds are intramolecular forces, and metallic bonds are intramolecular forces. They are bonds that hold atoms together within a particle. Now, what about the bonds that hold water molecules together to form a liquid or solid? Now, these are not called intra. These are called intermolecular bonds. So how do water molecules stick together in the liquid or solid phase? And that's what we're going to be talking about in our next videos, intermolecular bonds. So we'll see you soon. Short video today. Enjoy the rest of your evening. Bye-bye.